Welcome back to my YouTube channel. Today we are going to solve hard question on lead code, maximum number of points from grid queries. Let me read the problem statement. We will be given a grid of m, comma n size, and there will be a queries of size k. And for each query, we will have to calculate something out of this grid which is nothing but we'll have to start from top left, which is this one, and we'll have to do following steps based on that. If query of I is strictly greater than value of the current cell, then you are in, then you can get 1 point. If you are first time visiting the cell, like if you are visiting for this first time and this value is less than the given query of I, will get a point. And you can move to the adjacent cell in four direction, which is top, up, down, left, and right. Otherwise, we won't be getting any points, and we can end this point process. After the process, return the maximum number of points you can collect. And for each query, you are allowed to visit same cells multiple time. Okay. Uh, what based on the question, what we can do is for each query, we start from top left and let's see what are all uh, whether we can collect a point if it is not visited and it is less than 5 and we can collect a point and we will try to traverse in four direction. We kind of use a breadth first search like queue to process these nodes, and we'll keep doing until the queue is empty. And we will be collecting the point and return the answer. That will be the maximum points we can collect. So here, if we see the constraints, m comma n is rise between 2 to 10 power 3, and uh, so the number of cells in the grid can be 10 power 5, and queries are nothing but 10 power 4. So in total, we will be having 10 power 9 operations. Like if if you are following the brute force approach, so for each 10 power 4, uh, we will be traversing the entire grid. So let me try to solve this one, and it will definitely time out because of the constraints. First, we will implement the naive approach and see how we can uh, optimize it. So let's just code this up. Um, okay, this is for the let's say we need a result array. Uh, which will be having the size, and we will return the result. Uh, Now, for each query, we will calculate the points count. Let's say for now, we'll call it count, and we will pass in the grid and the query, right? Let's just define this method. We will be returning an int, and we pass in the grid uh, and k. let's call it K, and let's call it rows is equals to group dot length and columns is equals to, right? Now we will be creating a queue and no linked list. Let's use linked list to process and queue dot add. We will be placing the top left based on the question. We will be starting from top left, and the data type should be int. Now we will be needing another array to track the visitor nodes. So visited is equals to let's call it boolean as passing number of rows for each cell. Okay. Now let process the queue now until queue is not empty. And so let's uh, where current cell is equals to queue dot poll. Okay. Now queue dot current cell of 0 and current column is equals to current cell of 1, right? And what we can do is uh, uh, let's assume these are not visited, and we will be inserting in the queue only if let's check this one first. If grid of current row comma current column uh, this grid is gonna equals to k, we'll just continue, otherwise we will calculate the points. We need a point, we need a variable for counting the points as well. In the end, we will be returning the points. Okay. Now we will be needing a direction array. Uh, we need 4 direction. So let's define that. -1. Okay, these are the directions based on the question. What else we can do is uh, for possible direction, directions, and the next row will be direction of 0 plus current row, and the next column will be current column, which will give the next, which is adjacent. Now let's just check. These are all valid. Next row less than greater than or equal to 0, and next row less than rows, and next column greater than or equal to 0, and next column less than cos. Then we will be adding into our queue directions. Okay. Uh, Next row and next column. Got it. Uh, what else we can do is also this cell shouldn't be let's say uh, if visitor of next row, next column, we will just continue. Else, we will mark it as visited. Got it, right? Uh, for the first one also, I will do the same thing. This will be 0. Whenever we are inserting, we'll just mark it as visited. Uh, I think that is, let's try to submit this solution first. Uh, yeah, basic test cases are getting passed, but this will fail due to TLE, time limited exceeded. Uh, we will have to optimize some part of it. I'm going to explain that now. As you can see, there is only 17 test case got passed. Let's see how we can optimize this one. Uh, if you see the queries, it doesn't matter which one you solve first, right? So let's say if we sort the queries and if we solve the query which has less value and we solve like we traverse the grid, uh, then we will only traverse like we collect points from which are less than the current query value, right? And if we solve for the next query, which is query plus one, let's say, and this query, the second query contains points from the previous one, plus some other uh, queries, right? Some other points we can collect from the grid, right? And so on. So if you get that observation, uh, may, making use of this point, can we do something here? Uh, Instead of here we are always starting from the uh, top left, right? Uh, since uh, we sorted the queries and we are solving for the less value first, and we collect some points, and in the next query, the previously collected points will also be a part of it because we are solving for the greater value, but we'll have to search for the remaining cells, right? So, how we can do it? Let's say in the queue, instead of using the linked list, let's try to use a priority queue where we will be storing the uh, min heap, min heap. What we will do is as long as the as long as grid contains value less than this k, we will be inserting into the queue and we will process it. And till we, whenever we reach empty or the heap contains uh, greater than k, we will stop there. and these are the points we collected for this k value. So based on this, we will try to implement it. So let's just, since we are sorting the queries array, we will have to have an index pointing to that after the sorting, right? So we will be doing that now. I less than size I plus plus. Uh, we will be needing a new array. Let's call it sorted queue, which is nothing but we will be having one for the query value and one for the query index. So here sort is equals to for query value we will be using queries of I and sort query I. In the one index we will be storing the indices, right? Got it. Now instead of this one, what we can do is sort of queue query. Uh, we will get the index uh, sort queue, right? Uh, we don't need this variable anymore. We will have to sort the array as well. Arrays dot sort sort queue, and let's just say q2 integer dot compare q1 of we will be sorting the query values. So uh, got it right. Now just modify the actual logic here. Instead of linked list, we will be using an hash map, like a mini. So that is priority queue, right? And we will be needing, uh, since we are inserting an array, we will need a comparator. So we'll use some, let's call it element 1 and element 2. We will be storing three values here, the actual grid value and the row and column. So we will be storing the grid value in the first index, like which is 0th index. So that will be E1 of 0. Uh, let's just write integer dot compare uh, E1 of 0, comma E2 of 0. Got it? Uh, what else we can do? Here we will be rid of 0. So we will be storing value, row, and column. And we will have to have the value, current, current value. And this will be 0, 1, and 2. Got it right? Now this queue will run either the queue size is not equal to 0, and what we will do is uh, queue dot peak of 0 which is less than this one. Size is not equal to 0, and we don't need because we will only inserting the value which are uh, and also uh, this visitor should be edge global with respect to this method. So we'll have to pass in the uh, visitor as well. So let's just move this to here, and we will be needing the rows and columns. We'll just copy paste here, note it. Uh, so in the count method, we will be having boolean of visitor. Uh, I think for now, let's just move this logic uh, to and completely uh, to here. And this thing, okay, we will be needing points as well. Uh, where points will remove this one. Now let's copy this entire thing. Mm, um, okay. Okay. And passing next row, next column. Let's try to run this. Uh, Basic test case for passed. And are we using this current value anywhere? That's it. Uh, Wrong answer. What we are doing is queries dot len size. Let's try to debug it. Okay. We can just add it. Maybe it might be this will stop if k greater than 0. This will not execute and points remains the same. So this shouldn't be here. So I think that is it. Let's refactor a little bit. These are the variables. Okay, let me try to submit the problem. Accepted. Let me try to write the time and space complexity. Okay, for the time and space complexity, we were traversing the queries array. Let's say q times here, and we are sorting the queries, which is q log q. And so based on these two, we can say q log q. And also we have created one array here of size q and rows comma columns here, and also define the queue and of in three variables. At max it will have rows time columns, this priority queue. So we can say space will be rows times columns plus big rows time columns plus big of queue. Okay, queue is the number of queries, and let's call this big of queue inside it. And coming to the time complexity, we are processing this take queue log queue, and we have initialized the priority queue. We are adding element, and adding takes logarithmic time. It will calculate up. And for queue queries, uh, each time what we are doing is uh, whatever the we for a given query, we might end up with traversing all the queries, and somehow this will run n times m of a queue query. Let me see the time and space complexity of this solution. Uh, is correct. And K log K is also correct. What we are doing is inside we are processing the queue which has n times m, and every time we are doing log K operations. Uh, uh, Maybe please let me know if you know the time complexity of the solution. I was a little bit not clear on this, but according to the editorial, it says K log K is understandable because we are doing sorting here, and here we are removing element which is log K every time, and we will be keep doing this for n times m. For each query, it process the cell using main heap. In the worst case, all cells processed and pushed into the heap. Each heap operation, push pop, takes n time, and therefore n time. I was a little bit confused that this Q times K. Got it. Please let me know if you get the intuition behind the time and space time complexity. And thank you for watching this video. Uh, Please like, share, and subscribe to my YouTube channel. See you next time. Bye.